Welcome to Data Structures and Algorithms Part 3. And today we're talking about recursion. This is the second video, and in case you hear a sharp noise, it's the parrot in the background. Let's get to it. And yeah, let's get to it. So why recursion is a complete loop? That's what we're talking about. And to explain it really well, I think it's best always to have an example. So we will use an example here. I think that the same example we've been using in the other videos. And yeah, so what we're trying to do in this example 3 is that we have, and this is a question you're going to see when you start solving a lot of data structure and algorithms, is we have this array now, and as you can see here, we want to print this array like this, and we also want to print it in the reverse order. And we can use recursion to do this. You could also use a for loop, but with recursion, it's much more easier. And yeah, it really explains how recursion works. So the way we do it is, as we did earlier, we have our termination condition. And our termination condition says if I is less than or equals to array length. That's just basically saying stop when we reach the end of the last digit of this array, we will return. And then we have our logic, our business logic or logic, which is to print the elements, the individual elements that I is acting as our index here. I want to print the elements in each index of I. So, and then after that, we have the recursive call right here. And yes, we talked about this earlier. We print this 1, 2, 3. So the reverse way is we have our termination condition for sure, because that's the first thing. When you're making a recursive function, you have your termination condition first. But the second part, you can see a difference there. We have our recursive call first. There's no business logic first. We have the recursive call first. So we're going to call the function first. And then lower there, we have our logic, which is to print the individual indexes of I, to print I. Yeah, so how does this come about? How does this print? How does this print it in the reverse order? That's what we're going to talk about next. Yeah, this is just to show that it's basically opposite. In this side, where we printed the way it is in where we printed the, I would say normal way. Yeah, we have the logic and then the recursive call. In the other part where we print in the reverse, as you can see here, we have the recursive call and then the logic. So let's dry run this, because when we dry run it, it makes more sense and we understand it more. So the first one here, the right order, or the way it is in the array, where we want to print it like that, we start with I equals to 0. And then I gets logged. That means I gets printed. And then I gets incremented when the function gets called. That's when the function gets called recursively. And then so I becomes 1. And then, yeah, it starts all over again. And 2 gets logged because 2 is the one index here is the value 2. And then I gets incremented again. And then the third time again, I becomes 2. And the second index here is 4, the value 4. And then I gets incremented, I becomes 3. The moment I becomes 3, I is equals to the length of this array, which is 3. So what happens is we start returning, and this part of returning is we're going back. We're going back, and then we go back to where we started, and only when we reach where we started, then we print out, then we return out of the function. When we get back to where we started, we return out of the function. I know we talked about this earlier, but now let's look at the reverse, printing it in the reverse order. How does that work? So printing in the reverse order is the same again. I is equals to 0, and I gets I gets called recursively and incremented, but I hasn't been printed yet. So that's the difference here. So then we go to the second one. I is incremented now, I is equals to 1, and then I gets called recursively again. So I is now 2, it gets called recursively again, then I is equals to 3. That means I is equals to the length of the array. So when I is equals to the length of the array, that's our termination condition we just hit, and now it's return. But as we said earlier, it doesn't return straight. So it goes back. So I goes back to this part where it was 2. And as we can see here where it was 2, we still have this console.log r index I. So that's what we do next. When we go back to 2, we check whatever is below where we got called recursively, and we do whatever is there. So that's when index 2, which is 4, gets printed. That's why we have 4 right here. And then after we've done that, then we go to the next one, which is I index 1. Index 1 here is 2, then 2 gets printed. Then we go to I index 0. Index 0 is 1. 1 gets printed. And then we return. As you can see here, 4, 2, 1 gets printed. So this explains it well. The summary of this example is that number 1 is a termination condition. That's the first thing you do when you're making a recursive call or a recursive function. The second part, you can switch them up depending on the type of problem you're solving. So you could put the recursive call before your business logic or your logic, or you could put the recursive call after you put your logic, depending on what you want to solve. And in this case of reverse, we put the business logic after the recursive call. So that made sure that the business logic or whatever code was in the business logic would only perform when the recursive function is being returned. I hope that makes sense. If it doesn't, listen to the video again. Repetition helps in scenarios like this. Sometimes you have to listen to it 3, 4 times and then like a light bulb appears and stuff. So we have another question because it's good to ask questions. You have to be curious when you're dealing with like data structure. Just in life in general, you have to be curious. So how does recursion work internally? How does it work internally? Well, I got the answer. Let's figure it out. Recursion is supported by a data structure called Stack. And if you've heard about Stack, that's good. If you haven't heard about Stack, that's good too. We are going to cover Stack in full depth in later videos, but we will briefly touch on it because it really is involved with recursion, as we can see here. Recursion is supported by a data structure called Stack. And Stack has this principle, or the way Stack functions is it is first in, last out, or last in, first out. And the way of imagining it is just like having a plate, a bunch of plates. You know what? Let's check the next video. So you see this this video I don't know what to call this. This lines. You could imagine them as plates, or you could just imagine them as lines. Depends on what makes you understand it better. But as you can see here, the first line here that we put in this is right here. So the first line gets out. If we were taking it out, if we want to take the first line out, it would have to be the last one that comes out. And then the last one that goes in is the first one that goes out. So that's what we're really talking about here in the first in, last out. That's how Stack work. And we will talk about it later. So if it doesn't, I just want you to understand how recursion works internally. And you have to know this to understand that. And like 80% of people who think they know recursion don't understand this. So this is why we're touching on it because it's really important. So the underlying data structure that facilitates recursion is Stack, as we discussed earlier. in any language, Java, Python, Scala, any language, whenever you execute any function or method, a call stack gets created. So you see, when we're dealing with recursion, we're dealing with functions. When you when you um when you execute any function, a call stack gets created. And here, just to explain that really easily, is you can see here also. We can see it. You don't have to worry about this push or pop or empty stack. I think that's quite logical, understandable. Yeah, so you can see here we put in one, and then we put in two, and then we put in three. To take out the last one that we put in is the first one we're going to take out. And then the first one that we put in is going to be the last. I hope that makes more sense too. I'm just repeating it so yeah, so it's you understand it. Yeah, so when the function gets called, which is happening right here, this metadata here gets stored in our call stack. And after that, we go down and wow, we have the recursive call, which also increments I. And the moment we reach that place, what happens is I gets incremented and this metadata here too gets stored in our call stack. And then I gets incremented again. And then as I gets incremented, I is equals to 3, I is equals to 2, this is step 3, that gets stored in our call stack. And as this gets stored in our call stack, what happens next is that the fourth one gets stored in our call stack, which is this here. But this also certifies our termination condition. And the fact that it certifies our termination condition, we reach the return. And the way stacks work, and this is the way functions work, is that when we return, we first have to empty this stack before we can return out of the function. So as we can see, and now it's time to empty the stack. So this gets terminated, it gets deleted. It's been stored, now it gets deleted. Then we go to our step 3, which gets deleted. But also before it gets deleted, we do whatever we have to do in here. And in this case, we have to print this our array index I, and I is equals to 2. So we have to print 4. So 4 gets printed, and then it gets deleted. And then we go to the next, the same one too. The console.log here, it gets printed, and then after that, the call stack gets deleted. The metadata gets deleted. And then also here too, in step 1, the console it prints it does the logic or whatever we have to do in the function or whatever is in there. If there's nothing here, it does nothing. If there's something there, it does it, and after doing that, it gets deleted. And that's how you can see here that we get this printed in the reverse order. This is through call stacks. I hope this makes sense because it's really the foundation of functions and how functions work, and also how to use recursive function. So yeah, hopefully it's made sense. If you enjoyed the video, give us a thumbs up, like the video, subscribe to the channel, and if you have any questions, leave them down in the comments below. And that's it for now. Part 4 or 5, I'm not sure which one, will be coming soon on our data structures and algorithms course. So yeah, keep your heads up for that. Bye.